Now we will discuss about the value of the equivalent resistance or resultant resistance or the total resistance when a number of resistors, means you can take 2 resistors or 3 resistors, are connected in series or parallel. So first of all we will discuss about the resistances connected in series. In the previous class already we discussed what is the difference between your series connection and parallel connection. Now suppose this is resistance R1 and this is resistance R2. Both are connected to a cell. This is your positive terminal and this is negative terminal, and current I is flowing. And the potential difference across the cell is your suppose V. Now these two resistances are connected in series because the one terminal of resistance R1 is connected to the another terminal of resistance R2 with the help of a connecting wire. So the current will remain same for resistance R1 and R2 because the current is flowing through one path. The path is not divided here. So current for resistance R1 is also I and for resistance R2 is also I. But the potential difference is divided. That means for your R1, suppose the potential difference is V1 and for R2 the potential difference is V2. But the total potential difference across the circuit which is supplied by the cell, that is your V. That means you can write down V is equal to V1 plus V2. Clear? Now, according to Ohm's law, V is equal to IR. So, applying the same formula for the resistance R1, we can write down V1, current remains same, I R1, and for resistance R2, the potential difference is V2, so V2 is equal to I R2. In both cases the current remains same. Now putting the value of your V, V1 and V2 in equation number 1. So V is equal to IR. Instead of V1 you can write down IR1 and instead of V2 IR2. Or you can write down IR is equal to, take I common from right hand side, so R1 plus R2. Now cancel I from both sides. Now the equation becomes R is equal to R1 plus R2. Or you can write down R instead of your RS. RS means the total or the resultant resistance or the equivalent resistance in series connection is equal to the sum of the other resistances. So if we connect more than 2 resistors, the equations become RS is equal to R1 plus R2 plus R3 up to Rn, where n is the total number of resistors. So the final formula for your series connections, when n number of resistors are connected in series, the resultant resistance is equal to R1 plus R2 plus R3 plus Rn. Now we will discuss at least 2 to 3 examples based on this formula. Suppose we have 3 resistors and each of value 3 ohm. Units of resistance is ohm. Are connected in series. Then what will be the value of the resultant resistance? There are 3 resistors and value of each resistance is 3 ohm. So applying this formula, R or Rs is equal to R1 plus R2 plus R3. Now put the value of your R1, R2, R3 because these are your identical resistors. That means each of value 3 ohm. So 3 plus 3 plus 3, that is equal to, that means the value of the resultant resistance is 9 ohm. Clear? Now if we take 5 resistors, each of value 1 ohm, then what will be the value of your resultant resistance? Applying the same formula, Rs is equal to R1 plus R2 plus R3 plus R4 plus R5 because there are 5 resistors. Now put the value of your each resistance which is equal to your 1 ohm. That means 1 plus 1 plus 1 plus 1. That is equal to, so what is the value of the resultant resistance? That is your 5 ohm. Now we will discuss about the parallel connection of the resistors. Resistors in parallel connections. Suppose we are considering 2 resistors, R1 and R2. This is in your series connection. But now we have to connect these 2 resistors in parallel. Parallel means the path will be your multiple paths. So instead of placing the resistance R2 here, if we place here, that means R1 is also connected to a common point and R2 is also connected to the same point. Here the terminal of R1 is connected to here and the terminal of R2 is also connected to the here. That means A and B, these are the 2 common points where both the terminals of R1 and R2 are joined or connected. So this type of connection is called as a parallel connection. Now it is clear what is the difference between your series connection and parallel connection. In series connection, the path will be along one path. That's why your current will be same. But observe the diagrams. This is your cell and the potential difference is your V. And the amount of current is I. Now, after reaching the point A, the current for your R1 will be divided. Similarly, the current for R2 will be divided because the paths are different. That's why your current will be different. So, for your R1, suppose the current is your I1 and for R2 the current will be your I2. But the potential difference will be same because it is supplied from the same. Only one side is connected here. Clear? So we can write down the total amount of current which is equal to here I at the point A is equal to the same amount of current at the point B. That means the amount of current entering at the point A is equal to the same amount of current leaving at the point B. But after reaching at the point A, for the resistance R1, the current is divided, which is equal to I1, and for R2, that is I2. That means, in other words, we can write down I is equal to I1 plus I2. Clear? So, we can write down I is equal to I1 plus I2. Suppose this is equation number 1. Now, using your Ohm's law, which is your V is equal to IR. So, we can write down here I is equal to V divided by R. Similarly, for I1, you can write down potential difference is same, but the resistance is your R1. Similarly, for your I2, V divided by your R2, because the resistance is your R2. Now, put the value of your I, I1 and I2 in equation number 1. So, instead of I, you can write down V by R, I1, V by R1 plus I2, V by R2. Now, take common V from right hand side. So, the rest part will be 1 by R1 plus 1 by R2. Now, cancel V from both sides. So, the equation becomes one divided by R is equal to 1 divided by R1 plus 1 divided by R2. So, this is the final equations of the resultant resistance when two resistors are connected in parallel. Sometimes it is written as your RP also. RP means the resultant resistance in parallel. So, if instead of two resistors, if we connect three resistors or a number of resistors, then the equation becomes here 1 divided by R or RP is equal to 1 divided by R1 plus 1 divided by R2 up to 1 divided by Rn, where n is the number of resistors. Clear? So, in series, the value of the resultant resistance is equal to the algebraic sum of the individual resistance. That means R is equal to R1 plus R2 plus R3 plus so on. But in case of your parallel connection, the reciprocal of the resultant resistance is equal to the sum of the reciprocal of individual resistances. Now, we will discuss two examples based on the parallel connection. Suppose we have two resistors, each of value 2 ohm, but they are connected in parallel. So, applying the formula 1 by R is equal to 1 by R1 plus 1 by R2. Now, put the value of your R1 and R2, which is equal to your 2 ohm. 1 divided by 2 plus 1 divided by 2, or you can write down here 2 into 1 by 2, that is equal to 1. So 1 divided by R is equal to 1. Now you have to take the reciprocal of the both sides so that you can find out the value of your resultant resistance. So you can write down R is equal to 1. Now it is clear. Another example. If we connect two resistors of 3 ohm each and are connected in parallel, then what will be the value of the equivalent resistance or resultant resistance? So according to formula, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, because there are 3 resistors. Now put the value of your R1, R2, R3, which is equal to your 3 ohms. So that is equal to 1 by 3 plus 1 by 3 plus 1 by 3. Or you can write down here 3 into 1 by 3, because 3 times 3 will be cancelled. So 1 by R is equal to 1. Now take the reciprocal of both sides. So we can write down R is equal to 1. Always write down the units of that physical quantity. So now it is clear all about your series connection and parallel connections. Clear? Thank you.